Good day, humans, and welcome back to Prescription Sound. I am super excited for today's show because I am joined by Dr. Courtney Peterson from the University of Alabama at Birmingham, and we are talking all things intermittent fasting. Maybe you've tried this yourself or you know someone who is doing it, so let's get into the show and find out all about the science. So intermittent fasting does seem to be a bit of a buzzword nowadays, and I think everyone out there has heard of it, and they've probably been deluged with lots of information from different websites, health sources, magazines. So maybe you could just give us a specific summary of really what is intermittent fasting exactly.
So intermittent fasting is a general term used to describe any sort of dietary strategy where you're alternating periods of eating and extended fasting. Most people will use some sort of definition in about the 12 to 18 hours of fasting, meaning that any time you go without food or water for 12 to 18 hours, you are fasting. But there's no one set definition, so I think that makes it a little confusing for people. But on the other hand, I think part of this is because, when you think of extended fasting, the question is relative to what? What's your reference point? And I know Sachin Panda, for instance, who's at the Salk Institute, has a mobile phone called My Circadian app, or My Circadian clock, and they've looked at food intake patterns with this app, and what they found is the median person in the U.S. and also in other countries such as India is eating over a 15-hour period each day, which is pretty mind-blowing. But I think that's one of the reasons why we have some debate, right? Because if you think 15 hours is the norm, then you would say, oh, well, if you eat all your food in a 12-hour period and then fast for 12 hours a day, that's intermittent fasting. I tend to be a little more conservative myself. I like to define intermittent fasting as any sort of approach where you go for at least 14 hours without food.
Sure, yeah, thanks for clarifying that. And I guess we'll probably be using the term both intermittent fasting and time-restricted feeding in this podcast. So I guess time-restricted feeding would be condensing that feeding period into a certain portion of the day, whereas some protocols in intermittent fasting could be, every other day fast, or maybe 2 days fasting out of the week, that kind of thing.
Yeah, I like to tell people that I group intermittent fasting strategies into three broad categories. The first are kind of your pure intermittent fasting strategies. So these are strategies where you pick some number of days per week or days per month to have complete 24-hour fasts. Your second type of strategy I like to think of as your modified fasting approaches. So these are where you pick some number of days per week or per month to have a very low-calorie diet. And when we talk about a very low-calorie diet, we typically mean something like 600 to 800, maybe around 1,000 calories max from food. And there are three subtypes of intermittent fasting that fall into this category. So the first is alternate day modified fasting. The second type of approach is the 5-2 diet, which is kind of a lighter version of the alternate day modified fasting. And in the 5-2 diet, you pick 2 days a week to eat a very low-calorie diet. And then the third type of approach that's been studied in humans is called the fasting mimicking diet, or FMD. And so those are the kind of different types of modified fasting approaches, which people still often refer to as intermittent fasting. And then the third type, I think of these as your daily intermittent fasting strategies, which we now call time-restricted feeding. So these are strategies where you can eat in a smaller number of hours per day. So in effect, you're extending your period of fasting between dinner one day and breakfast the next. And time-restricted feeding is now the term that we use to describe this sort of approach. And I think what makes it different from the other approaches is and the other two types of approaches, the ones where you're either fasting for a complete day or eating a very low-calorie diet some number of times per week or per month. In those strategies, there's a specific calorie cut that you are aiming for. But with time-restricted feeding, where you're eating in a narrow period of time each day, you can either cut your calories or not. So there's just so much more flexibility and customizability with that kind of approach.
Yeah, completely. I know it's a lot more intuitive for some people. I know people have been playing around with this themselves, but it's really cool to now start seeing this stuff being studied in a scientific setting. So maybe you could just tell folks how you got into this kind of work. Have you always been interested in nutrition science, or what's your background?
I had been interested in nutrition and actually physiology a bit as a child. I was very athletic. I played 4 sports in high school, took weightlifting in high school, just thought it was really interesting. I had even a phase where in middle school, where I thought bodybuilding was so fascinating, and my parents didn't know what to do with, a teenage girl who wanted to order all these bodybuilding magazines. And I just thought it was this really interesting combination of art and science. And then I went to college, and I didn't end up going to a college that had a strong nutrition or exercise program or anything like that, but I knew I loved science. And I kind of dabbled with a bunch of different topics, but ended up actually doing physics. So I ended up, for my PhD, studying the physics of the Big Bang, so what happened in the early universe less than a second after the Big Bang. But I realized that we had a ton of different theories about what happened, but we couldn't really prove whether any of them were right or wrong. And I just thought, if I got to the end of my career and I spent all this time, thinking about the universe, which is fun, but, I hadn't really advanced humanity, I'm not sure I would be happy with that. And the whole time I had been interested in health, but I kind of saw it more as a hobby. But over time I realized how important it was to better study nutrition, diet, and exercise. And by then I had really thought about how powerful people say the benefits of fasting are, but I thought for myself, hey, I'm a pretty motivated person. I'm willing to try a lot, but just the thought of doing 7 days of fasting just didn't seem appealing to me. And I just kept thinking, is there a way to get some of the benefits of fasting without doing these extended fasts? So by the time I'd gotten to the end of my PhD, I knew I was already attracted to this field of daily intermittent fasting. So I ended up switching and doing my postdoc in nutrition, and that was in 2011. And then 2012, Sachin Panda's lab published an article showing that eating in an 8-hour period dramatically improved body weight, improved blood sugar control, cholesterol levels, reduced inflammation relative to grazing throughout the day. And the really special thing they had done in the study is they had matched food intake. And this kind of flew in the face of a lot of the advice that we've been seeing over the years that says, hey, graze throughout the day, it'll keep your metabolism revved up. And I saw his study and the results were phenomenal, and I thought, wow, this is amazing. We have to do that in people. And that kind of sealed the deal for me.
Wow, that's such an interesting background. So from bodybuilding to cosmology, I feel like I could ask you absolutely anything on this podcast. It's funny that you mentioned that a lot of people kind of find these protocols extreme, and it does sound extreme in the context of what we're used to, the way we eat in our modern world. And it's likely that in our ancestral times we didn't historically have access to food around the clock, and I know people are having all kinds of success with these protocols, from body composition to things like improved focus and cognition. But which kinds of populations do you think benefit most from intermittent fasting, and are there any instances where you don't think it would be appropriate?
Yeah, so the part about what's extreme or not, I think we sometimes assume that whatever we have in our modern society was the way things used to be, meaning, back, during critical points during our evolution, we ate throughout the day. Right. But I think, there are a couple pieces of evidence that suggest that maybe this time-restricted feeding is not extreme and is actually the norm. So one, if you look at some of the diaries of people many centuries ago, they tended to eat 2 meals where their biggest meal was actually around lunchtime. Because in the evening, they didn't actually have modern lighting, so they weren't eating late in the night as much like we do today. And then the second piece of evidence I'll give is studies of primates in the wild show that they tend to eat their food within about 9 hours or so each day. So I think they'll typically start eating, in the morning at a reasonable hour, but then they have their last large, feeding bout around 3 to 5 p.m. So I think there's some data suggesting that eating late into the night around 7, 8, 9 p.m. may not actually be the norm. And then your second question about who intermittent fasting is appropriate for. So what we know is that intermittent fasting dramatically reduces cell proliferation rates. So based on that, we think intermittent fasting is not appropriate for people who are growing. So for instance, teenagers, adolescents, children. It's not appropriate for individuals who are pregnant or breastfeeding. It may not be appropriate for other individuals, maybe in late stages of cancer where you're trying to keep weight on. It's hard to know right now. And then there's some question about its appropriateness for, say, individuals particularly with type 1 diabetes. So there was one study that came out recently in humans when I think they found slightly more hypoglycemic events, so in other words, low blood sugar in individuals who have type 1 diabetes. I think we also don't know yet how good these programs are with individuals with eating disorders, and no one's tested that yet in humans.
Yeah, those examples are interesting, and it's something for people to know, because I think sometimes when people get into following these kinds of things, they treat it a bit like a religion and not realizing that everyone's kind of individual and it's going to differ from person to person.
Yeah, and it's also interesting that if you look at the data on intermittent fasting in humans, not all intermittent fasting approaches are beneficial. So the longest randomized controlled trial on intermittent fasting was just completed about a year ago, and it was a study on alternate day modified fasting in comparison to normal daily dieting. So meaning participants all cut their calories by the same amount on average, but some groups did it by alternating overeating and undereating, and other groups did it by, cutting their calories the same amount every day. And what she found in that study is actually the intermittent fasting, which is actually no better at improving weight loss, and it didn't improve any other diabetes or cardiovascular disease risk factors relative to daily dieting, suggesting it's equivalent, it's no better or worse than daily dieting. However, the one caveat is that people who did the alternate day modified fasting for a year, they dropped out of the weight loss program at a higher rate than those who did daily dieting. So that, to me, is actually a negative on alternate day modified fasting. So I, in general, don't recommend it. There have been studies of intermittent fasting where they find that fasting during the daytime and then eating all your calories in a narrow time period late at night actually may worsen health. So, historically, if you look at the people who have done clinical trials on intermittent fasting, they've just kind of assumed that, okay, if you fast, regardless of what time of day you fast, you're always going to get kind of the same results. So we might as well just pick a convenient time each day that we'll have people eat and a convenient time when we'll have them fast. I think the data are now showing that that's not the case and that our internal biological clocks matter.
Yeah, that's a good segue when you're talking about food distribution and timing, because another component of your work I know is, and another reason why I was so enthusiastic to have you on the show is because you're also a circadian biologist. So I myself work in a lab at Scripps that studies the circadian clock, and when I tell people this, they usually assume that I study sleep. Even though this aspect is important, there's obviously lots more to it. So maybe you could give the listeners a summary of the circadian system in general, and then how it applies to when we should time our food intake.
Yeah, absolutely. And I'll just preface this by saying I consider myself a jack of all trades, master of none. So I straddle both the intermittent fasting metabolism side of this kind of research as well as the circadian side. So, I have some expertise in both, but it's not as deep, for instance, as people like you who mostly study, all the different circadian pathways. So what we know is the body has an internal biological clock called the circadian system. And this clock basically regulates your metabolism and physiology and behavior in these approximately 24-hour cycles. So what that means is your body is better at doing different things at different times of day. So for instance, your best sports performance is in the afternoon. So if you're going to have a race, the best time to do that is in the afternoon. You're best able to fall asleep in the evening, and that's because your body produces a hormone called melatonin, which helps you fall asleep. And then conversely, the best time of day, it looks like, to digest your food is in the morning. Your blood sugar control is a little better in the morning. And actually, another thing we know about the morning is the morning is the time of day when we have the sharpest rise in our blood pressure. And so as a result, most people don't know this, but Monday morning is the time of the week when we have the greatest number of heart attacks. And the reason why it's Monday is usually the most stressful day of the week for people because they're coming out of the weekends. And then second, the morning because of the circadian system. So, these 24-hour cycles have real consequences for our health. And what's particularly interesting for me, because I study metabolism, is your blood sugar control is actually substantially better in the morning than it is in the afternoon and the evening. And we've known for, I think it's now been about 50 years that we've known that your blood sugar control is better in the morning than it is in the afternoon and the evening. But back then in the late 60s, we didn't know anything about the circadian clock. So, I think these blood sugar rhythms were an interesting curiosity, but no one pursued them or kind of treated them seriously, which is ironic because, if you think about it now, it kind of makes sense. Okay, well, if my blood sugar control is best in the morning, maybe I should eat in the morning or eat most of my food in the morning because then, I'll be in alignment. I'll have better blood sugar levels overall. In addition to blood sugar control, we also know that when you eat your food, you burn slightly more calories when you eat in the morning. You digest the food a little faster. We also know that your lipid levels seem to peak around noontime. So everything kind of points to, I'd say, the mid-morning to around noontime as being optimal for food intake. And what's really interesting, most people don't know, is that the circadian system is not actually a single clock, but it's a bunch of clocks throughout the body, and you can think of each organ or tissue as having its own clock. So we have a master clock in the brain, which you can kind of think of as the conductor of the orchestra of all the rest of the clocks. And what's interesting about that clock is, in order to create or generate these 24-hour rhythms, it itself has to know, what time of day it is. And the way it knows what time of day it is by when you get bright light exposure. So this is the whole basis. How do you adjust to different time zones? Well, that's based on when you get bright light exposure. The rest of your body also has a series of clocks, and each of those clocks similarly can create or generate their own rhythms, and they also need to know kind of what time it is and therefore, where they are in their cycle to generate these rhythms. And what's interesting about the rest of their clocks is, they get some clues from the master clock, but they also get clues from, when you go to sleep, your physical activity, and so forth. But what we think is the most important factor in determining their effective time zone, per se, is actually when you eat. And this is really interesting because if you have basically two separate parts of your circadian system, one whose time zone is set by when you get bright light exposure, and the other whose time zone is set by largely when you eat, what this means is if you're eating out of sync with when you're getting bright light exposure, it means your clocks are in very different time zones. And as a result, they're kind of giving your metabolism conflicting signals about whether to rev up or rev down. And so we think this creates problems.
Yeah, such a good summary. I think with these rhythms, we like to say they're internally generated but externally influenced by all these different time cues.
Exactly.
And it really just affects so many different processes in the body. And when you were talking about glucose regulation and insulin sensitivity, it made me think of your really great recent study where you combine both this kind of circadian alignment issue and time-restricted feeding in a population of pre-diabetic men. So maybe you could just go over some of the aspects of the study and what you found.
Sure. So I wanted to be very specific and say, okay, let's try time-restricted feeding in humans, but let's do it really early in the day so we are in very strong alignment with these circadian rhythms. So one of the things that really inspired me about such a study is that they matched food intake. And I think this was really important because there had been some studies that had done experiments with time-restricted feeding before, but they hadn't really matched food intake or hadn't done studies that were as carefully controlled. And it wasn't until his study, checked all the boxes and did everything so rigorously that people took it seriously. And so I kind of wanted to take a similar approach here. So I was very interested at the time in the question, can intermittent fasting have benefits independent of how much you eat and independent of whether you lose weight? Because that was the big question in my head, because if you have a sort of strategy and it improves the health of different people, but those people also lose weight, then a lot of other scientists will say, well, of course their health improved. They lost weight. How do you know is anything special about what you did? And so I really wanted to nail the question, does intermittent fasting have benefits independent of effects it may have in helping you eat less? So in the first study, we were very much interested to see whether time-restricted feeding could improve blood sugar control. And we wanted to do this in people who already have impaired blood sugar control, so that if there is an effect and it does improve their blood sugar, we'll see an effect. And so I was also very interested in the question of, can we use this as a therapy to treat people who have problems with blood sugar control or who potentially even have diabetes? So in this study, we took 8 men who have prediabetes, and what we decided to do for this study was to feed them all of their food for 5 weeks at a time. So they tried both time-restricted feeding, and they tried just, a normal eating schedule. And they tried each of those for 5 weeks at a time, and they had a 7-week break in between. During each 5-week period, we made and prepared all the food for participants. We fed them 3 meals a day, and we measure out all the food that we provide to them, and we measure it out to the nearest gram. So these are very demanding studies. They require full-time kitchen staff, also kitchen staff to be there at night to help supervise patients. We also would allow our participants to eat some of their meals on Skype too, and they had to show us every single thing they were eating, and then we would supervise them that way. So these are very hard studies. Not many places in the U.S. can do them, but they're super rigorous. And the exciting thing with these kind of studies is if you see a difference, you really know it's not due to any differences in what the participants are eating. And then we also made sure to feed them enough to maintain their weight. So we had participants follow either a time-restricted feeding schedule or a control schedule. So for the control schedule, we had them eat over a 12-hour period. So, for instance, if a participant wanted to eat breakfast at 8 a.m., then they would eat lunch at 2 p.m. and dinner at 8 p.m. And then for the time-restricted feeding schedule, we had them eat over a 6-hour period. And we required that 6-hour period to be early in the day. For instance, if someone wanted to eat breakfast at 8 a.m., then lunch would be at 11 a.m., and then dinner would be at 2 p.m., and then they'd fast for the rest of the day. So pretty extreme schedule, given that we're comparing basically eating within a 6-hour period each day versus a 12-hour period each day. We weren't yet trying to find what's doable for most people. We were just trying to prove or see what, kind of the maximum benefits could possibly be. So they did this for 5 weeks at a time, and we measured their blood sugar control before and after. We also would measure their insulin levels, and then we measured their blood pressure and some fasting indicators of their cardiovascular health. So we obviously measured different types of cholesterol levels. We measured some indicators of inflammation in their body, and then we also measured oxidative stress, which you can kind of think of as a form of molecular damage to molecules in the body. And what we found is that relative to the control schedule, the time-restricted feeding did not affect their glucose levels in the morning, or at least, we perform these tests only in the morning. But it did improve their insulin levels really dramatically. So the average reduction in insulin levels during the test was about 26 points. So it's a big drop. We also looked at estimates of what's called insulin sensitivity, which is the body's ability to process the sugar in your bloodstream and move it into your cells. And we found that insulin sensitivity improved dramatically. So it took less insulin to move the glucose out of the bloodstream and into their cells. We also calculated something called beta cell responsiveness, which is the ability of the pancreas to respond to the amount of glucose in your bloodstream and to produce insulin. And what we found is the pancreas was able to respond faster. So that indicates it's healthier. It's kind of better able to react to rising blood sugar levels and help keep them under control. So that was also really exciting. We actually since have done a 4-day study and looked at 24-hour glucose levels. And what's interesting is we do find that time-restricted feeding does reduce 24-hour glucose levels. You just might not see it if you only measure glucose levels during, say, the breakfast time. We also found that time-restricted feeding dramatically improved blood pressure levels, and it was quite a big improvement. So it was about a 10 to 11 point improvement in only 5 weeks. And that's, if you know blood pressure studies, that's pretty huge for a study with no weight loss. That's only 5 weeks long. And we're not exactly sure what explains it. So one theory is maybe the low insulin levels help drop blood pressure levels, because most people don't know this, but insulin can directly affect blood pressure regulation. Another possibility is that with the time-restricted feeding, the body was better able to excrete sodium in urine, and that might be due to a circadian clock type effect. So that's another possibility. A third type of possibility is maybe it's not due to the circadian clock, but it's just due to the extended fasting. So there is something called fasting natriuresis, which is basically this concept that when you do extended fasting, you excrete a little more sodium. So it could be due to that. So we're not certain yet, but it's all really interesting. So that was the largest effect we actually saw in the study. We did find that the time-restricted feeding increased triglyceride levels quite a bit. Normally, higher triglyceride levels are concerning. We're not particularly concerned because, everything else seemed positive, but also because the time-restricted feeding group, when we did those tests or those measurements, they had been fasting for longer. So it just might be some sort of reflection of the fact that they're burning more fat or have been burning more fat at that time of day. But we did find a reduction in oxidative stress levels. We found a reduction in something called 8-isoprostane, which is a marker of damage to fats in the body. And that's really important because we know atherosclerosis, or the buildup of plaques in blood vessels, is due in part to these damaged fats in your body. So lowering that is a really great thing. So that was the first kind of proof of concept study to show that intermittent fasting can have benefits independent of weight loss and independent of what you eat. So intermittent fasting's benefits are not simply because you eat less. There's something intrinsic to it. We don't really know, the one caveat is we don't really know whether the benefits we saw in our study were due to the extended fasting duration or the alignment with circadian rhythms, or it could be both. So we really don't know, and we kind of need to better tease that apart.
Yeah, these results, which you beautifully summarized there, are so remarkable. And when you were going over the details of the study, I have to say I just really liked how rigorously controlled they were, because a lot of people don't appreciate all these challenges that you get in nutritional studies. And by the way, that's an amazing use of Skype to just watch somebody trying to eat their dinner.
Yeah, it actually worked great because it gave our participants more flexibility, but allowed us to increase the rigor of the study dramatically.
And you mentioned that these are largely kind of proof of principle pilot studies. And for example, your first study that you mentioned there was on 8 pre-diabetic men, I think. So I just had a possibly interesting technical question, which is with these small sample sizes, you naturally get some deviation in your sample averages. So when you look at the data for each individual, do you find that they're all largely responding positively and there's just, variation? Or are you seeing some vastly different patterns of responses depending on the person?
Yeah, great question. Yeah, and I think you always have to be really careful with small sample sizes. Our sample size of 8 is small. For controlled feeding study, it's not as small as what you would think. Because when you have these very rigorous studies, you're reducing the experimental noise dramatically. In our study, when we looked at, say, insulin levels, we found 7 out of 8 people had improvements in insulin levels. The one person, interestingly, who did not improve was someone with a 20-year-plus history of shift work.
Oh, wow. Okay.
And that was kind of interesting to us because, normally when we do these studies, we ask people, well, do you currently do shift work or have you done it recently? And if their answer is yes, then we don't include them. But, we don't normally look back, that many years in the past.
Yeah.
And there is some evidence suggesting that people who are chronic shift workers may need different meal timing schedules.
Yeah, it's such a metabolic spectrum, probably depending on the health of the person. And sort of a follow-up question to that, which is, as you'd probably be aware, in science now, we're always trying to appreciate differences in outcome from any intervention due to differences in ethnic background or sex. So do you have any insights on how either the ease of implementation or the benefits of time-restricted feeding may be affected by race or gender differences? I know I've certainly heard some anecdotal things about its utility in women, but I wonder what your thoughts are on that.
Yeah, great question. I think we know more about the differences by gender or by sex actually in rodents, and there do seem to be differences. What I can tell you about the human data is women in response to fasting, their levels of lipids in their bloodstreams rises faster.
Right.
And so we do know there's some differences in how quickly men versus women respond. And I do know anecdotally a lot of women have, or I've heard people say, as women they found it a little, harder and men found it a little easier to do it. But they're really not great studies on this in humans. The only one that I know of in humans, they were looking at doing alternate day fasting. So this is where every other day you have a complete 24-hour fast. And in this one particular study, they found that the men had improvements in either glucose and or insulin levels. And I think the women, their postprandial glucose levels got worse.
Oh, wow. Okay.
And so that's potentially concerning. However, the big caveat is when we first did all these intermittent fasting studies, when we were trying to infer whether they improved blood sugar, we would usually only measure fasting glucose levels, or we'd only measure it at the end of the fast, meaning first thing in the morning after they completed their fast. And what we know now is every time you do, like say a 24-hour fast, your blood sugar control actually gets worse. So your insulin sensitivity gets worse. Your beta cell responsiveness or your pancreas's function gets worse. And what I mean by gets worse is like it acutely gets worse. So at the end of the fast, it is worse. But then you start eating again and, it gets better. So if we're only measuring the effects of intermittent fasting on fasting glucose or just glucose measured in the morning, we're missing the whole picture.
I was wondering if I could just ask you a question on this interplay of food quality and timing, because I know you said you were kind of passionate about food composition as well. So I was thinking about some of these animal studies with time-restricted feeding, and we see a benefit of extended fasting when the lab rodent, say, has a very poor diet generally, imitating a Western high-sugar, high-fat diet. So just kind of extrapolating this to humans with often our own poor diet. Do you think we'd necessarily see the same benefits of time-restricted feeding if we had a diet which was, say, more ancestral in its composition, devoid of all processed food?
I suspect we'll probably see a smaller effect, but still an effect. So I think it'll still be beneficial, just not by nearly as much. And I say that based on a couple of things. So one, we think, probably some of the benefits of the lower blood pressure might be due to the fact that the time-restricted feeding lowered insulin levels. And we know insulin affects a lot of different systems within the body, so simply lowering insulin levels with the extended fasting may be beneficial. And in fact, one of my friends here who studies low-carb diets, her suspicion is that if you're doing a low-carb diet and your insulin levels are pretty low, there's not a lot of room for you to improve. And I think the same is probably true if you're doing a healthy high-carb diet and your insulin levels are low. The other thing that I think is also worth bringing up here is, some of the original data on time-restricted feeding showed, for instance, in Sachin Panda's seminal 2012 paper, showed that even rodents on a normal chow diet did have improvements in some aspects of health. And what's interesting, and if you look at our individual data in our pilot study, individuals who had the worst insulin levels when they started the study had the greatest improvements in health, and by a long shot. So the more unhealthy you are, the more benefit you'll probably get from time-restricted feeding.
Cool. And I have to ask, has this kind of work influenced your own personal eating habits?
Yeah, absolutely. So usually Monday through Friday, I'll eat dinner between about, these days it's about between 1:30 and 4 p.m. It just depends on what sort of meetings I have. If I have a lot of meetings in the afternoon, like obviously I can't take a break for dinner, but a lot of the times I'm just done eating by 2:33 or even earlier. Just depends on the day. And on the weekends I just kind of play it by ear. But I frankly actually like it a lot. I feel a kind of like peacefulness from doing it, and it's been great for me. It's a little more complicated with going out with friends and stuff, but the place where I'm at is just if we're going out to eat, I just eat. I just don't even worry about it. So, and I kind of joke they're like my bonus calories because it's funny, I'm so highly adapted to it now, it's hard for me to wait and not eat everything, before mid-afternoon. So I end up overeating those days, which is totally fine.
Wow.
But it's a little funny sometimes, or a little comical, But in general, if people want to experience this or experiment with it on their own, I usually recommend that they start with an 8 to 10 hour period and see how that goes for them. I didn't find it easy when I first started. In fact, I found it difficult. Now I find it super easy to eat in a 6 hour period. I even had a period where I was experimenting for a while with 5 hours and didn't find that to be difficult, again, after you adapt. But, in my pilot study where we did 6 hours, we asked participants, how hard or how easy was it to fast? And what was really interesting is they said the fasting part, the 18 hours of fasting, was not difficult at all. In fact, they, thought it was fairly easy. But what they thought was difficult is eating all their food in a 6-hour period, and they said they just felt so stuffed, and it took a while to adapt to that. So, and we also asked them, okay, well, what do you think is practical for, the average American? And their average response was about 8 hours. So I recommend more like 8 to 10 hours.
Okay, cool. Yeah, I've been playing around with all this stuff and just continuously. And I find what's more intuitive and kind of fits better with a social life is often to not eat in the morning and then just kind of have lunch and then dinner. But yeah, I wonder, you've kind of inspired me to change things around. Maybe I should shift it.
Yeah. So the R1 that I'm doing will also compare time-restricted feeding early in the day versus late in the day. So we'll get to see how much the results are due to the length of the feeding versus fasting period versus the circadian timing of food intake. So I'm really excited about that because I think most people who are willing to do time-restricted feeding would rather do it by skipping breakfast than by, skipping dinner.
Yeah.
So I think for me the million-dollar question is, if you have to eat dinner at a certain time, should you skip breakfast or not?
Oh, yeah, couldn't have said it better. That's so great that you're going to be answering that once and for all.
Yeah, we're super excited about it.
Cool. I'll just finish up with my final question, which I like to torture my guests with, which is from all your experiences, if you could give one piece of advice or some wisdom to anybody, they could be a scientist, but they don't have to be, in the realm of just life, career progression, working, health, relationships, anything, what do you think it would be and why?
That's such a hard question. I'm going to give you a couple. I'm going to cheat a little. So one, I think life's an ultra marathon, and I think we often think that, whatever we're striving for will come in a few years, but I think, a lot of these great achievements that people have, they aren't going to come in 5 to 8 years. They're going to come more like 10 to 20 for most people. So you just got to pace yourself and have a lot of grit and determination. I think, that grit and determination is one of the most important factors. And I think the other thing I'll mention is just to do something that has high impact. That's why I really like the stuff I'm working on now, even though, it's hard in some of the things I did in physics. It's hard in a lot of other ways, but the impact is just so much clearer. It's just very clear to me that the research that I get to do now could potentially help millions of people.
Great insights from Dr. Peterson there, and such cool research questions that her lab is trying to answer. So huge thanks to Courtney for joining me today. In the show notes of this episode, we will have links to her research profile. And if you're interested in learning more about this topic, there will also be a link to a blog post I wrote summarizing this work, as well as direct links to the studies themselves. If you liked this episode, show your support on SoundCloud or iTunes and hit subscribe. As always, thank you for listening. More good stuff coming soon. Take care.